Hello students, we're looking at the solutions to the selection of multiple choice questions on our equations of the circle, the ellipse and the hyperbola. So let's look at question 1. We've got a range of an ellipse is from -2 to 6. Now the range are the allowed y values, okay, or vertical values. And from that we have to work out what is the equation of the ellipse, okay. So first off, we have to identify on our ellipse what are the possible minimum and maximum values. So there's an ellipse. So the minimum value is the vertex at the bottom, and the maximum value is the one at the top. So what are the general form for finding such coordinates? Well, the maximum one, the one at the very top here, that's going to be given by, well, this is a change in the y variable, the y value. So starting from the center, we're going to add the b number. Okay, this is the denominator of the y term. Alright, and then if we're finding the minimum, the one down here, the minimum y value, then we're starting at the center k and we're going to subtract that b number. Alright, so let's put them two together. The minimum of the y value is the k minus b. Well, that's given to as the -2 here. So that's your minimum y value. And your maximum y value, the 6, alright, is made up of the k plus the b. So if you consider them as equation 1 and equation 2, and I can solve that pair of equations using elimination method. So I'm going to add equation 1, add that to equation 2, and I'll get 2k is equal to minus 2 plus 6 gives me 4, and that's k is equal to 2. And having solved for k, I'm going to substitute that back into equation, maybe equation 2, and solve for b. I get b is equal to 4. So now I know my two parameters in my general form of the equation. Now, in the equation, the y term is going to look like this. For a k of 2, I'll have a y minus k, or y minus 2 squared, divided by the b number squared. So your b number here is 4, so we're going to get a 16 in the denominator. Now, let's have a look at all the possible answers. It's not in the general form, we've got it multiplied by a factor of 64. So if I think about dividing by 64 to each term, then what I'm having now, I need to end up with a fraction out of 64 that's equivalent to 1 over 16. Okay, and that's this one. So 4 divide 64 is 1 over 16. Okay, and we've got y minus 2 squared, which is what we're after there. Everybody understand? Fantastic. Let's have a look at the next one. Alright. So here's a graph of an ellipse, and the question is, a possible equation of the ellipse shown above is. Alright, so determining what is the equation of the ellipse just from the graph. Alright, so it's an ellipse, we've got to start with the general form of the ellipse. Alright, and from that we know also from looking at the graph, we've got the center point, which is this point here, is x equals -5 and y is 3. So there's your center. Okay, so from that we can already start to match it with a few equations. And also we know that from an ellipse, the horizontal axes, semi-major axis here, A, is the same as the A parameter in the general equation. And the point way over here is given by the equation H, start after H, and you add A for the k, and it has this coordinate 0, 3. So h plus a gives us 0. And the same with the vertical axis here, which is b units long. Well, that is a k minus b, the one at the bottom, and k minus b has a value of 0. So start at 3 and you subtract a b units to get to 0. Okay, and from that we can get B must be 3 units and A must be 5 units. Okay. So from that we can automatically eliminate a few equations, because by using the information about our center, in the equation it must be an x plus 5 and a y minus 3. So only these two are possible. The other three aren't possible answers there. Alright, now what's going to be the number in the denominators of our equation? Okay, so think about when we divide by 225 on both terms. Okay, here we're going to have a 25 divide 225. All right, how many times is that? That is 9. Okay, so having a denominator of 9 for the b corresponds to a b number of 3. Okay, so there we have it. There's the correct one. For an a number of 5, we get a 25 in the denominator, so we must have the 225 underneath the 9, so 9 divided into the 225, yep, that's 25 times. Okay. Good, let's have a look at the next one. Now, a hyperbola is defined by this equation, and the domain of the hyperbola is given by which one? So the domain here, we have to understand, domain means the allowed x values. Okay, so a hyperbola of a graph with asymptotes looks a bit like that, a bit of a rough sketch of a hyperbola. So your allowed x values are the x values where the graph is defined. So all the x values less than a certain amount here produces a graph, and all the x values greater than a certain amount here produces a graph. So our allowed x values on this graph are from this far vertice point here all to the left, which is negative, and from that vertice point all to the right, which is positive. And the part in the middle is not allowed. This little range of x values from there to there, they're not allowed. They are removed, okay, or they're the exception. We're going to exclude those x values. So in other words, if we just exclude this bit, the allowed values of x are all real numbers, except, that's what this notation means there, except or excluding a little domain of numbers here, from this value to that value, where 0 is right in the middle. Okay, now the minimum value of the minimum excluded x values is this one. Okay, the most left value. Well, that's given by h minus a. Okay, that's that vertice coordinate. The maximum value is this one over here, the most far right x value. Well, that's given by h plus a. And from the equation, we get a h of 2 and a number of 3. 9 square root 9 gives you 3. So you get a minimum value of 1 and a maximum value of 5 from that. So it must be e, because we're excluding net from negative 1 to 5. Okay, let's try another one. So here we've got this graph and this graph, which this looks like an ellipse, general form of an ellipse, while this one here is the general form of a hyperbola. Okay, and we're told that a and b are positive real constants, and we have to think about how many intersection points are there between these two graphs. They do not intersect at all, or they only touch at one point, or there's a number of intersection points. So let's get a general sense of what the graphs are going to look like. So on our Cartesian plane, there's our ellipse. So from this, we have, from the equation, we've got a center of a positive a for the x and a negative b for the y, taken from this equation. Okay, now this a and b are the same numbers as the a and b in the denominator. So if I start with h and I'm going to subtract a a take a gives me to 0. And if I'm going to start at y is equal to negative b, and I'm going to plus b units, I'm going to get to 0. Okay, so they just sit on the axes there. Now for the hyperbola, so that's the ellipse, and for the hyperbola we're going to draw it in green. There's my center, and it's going to look a bit like this.
Sorry, dude.
You're right. So from, again, just like we did with the ellipse, from the center we can work out the coordinates of the vertices by subtracting or adding a units, and again the vertices appear there on the, and once we put the graphs together we can see here we've got 2 intersection points, 1 and 2. Okay, so just having a general understanding of what the graphs are going to look like can allow us to form the conclusion that it must be 2 intersections points there for the answer. Alright, and one more, or 2 more I think. Now, the ellipse width equation given by this, alright, is an expanded form of equation of an ellipse. We have to determine the center and the major axes. So the major axes are the larger radius, so to speak. Alright, now on the CAS, the best thing to do here is to complete the square of this expression using the complete the square function on the CAS, and we would get this. Okay, now from that we can see what the center is straight away. Center is going to be a 1 for the x and a -2 for the y. So you can eliminate straight away 2 possible answers. That one and that one are eliminated. Okay. So, that's better. Now, when we divide by 144, we get these denominators, and from that we can work out what our A and our B number is. Alright, now the major axis is the one with the largest radius. So we say the major axis is the largest radius, and the minimum axis is the smallest radius. Alright, so in this case we've got the major axis. If we square root these numbers, we'll have a 4 squared and a 3 squared, so the A is 4 would be the correct answer there. So for that center and for A equals 4, we get that as our correct response. Okay, and finally, the ellipse given by this expanded equation has a center, length of horizontal semi-axes and length of vertical semi-axes respectively. Okay, so again, taking our expanded form, we're going to come up with the general form of an ellipse equation by completing the square on the CAS. We put that in the CAS, use the complete the square function, and we get this. Okay. Now, from that we have to work out what is the A number and the B number, where the A number is your horizontal semi-axis or your horizontal radius, and your B number is your vertical semi-axis or vertical radius. So let's rewrite it. There we go. So when it's by itself, it has a denominator of 1. So 1 squared gives you 1. Alright, so you've got an A number of 1 there. Now, this one doesn't have a denominator, yet it's got another factor of 2. So I'm going to write it as 1 over 2 in the denominator, square root, and then square it, and I get 1 over root 2 as my B number. Okay, so for that center, and for a horizontal axis, I have 1, and for my vertical axis, I have 1 over root 2. So that one must be the correct answer. Well, there you go. That's the scope of Year 12 multiple choice problems for looking at the hyperbola of the circle and ellipse equations. Alright, I hope that was helpful, and let's keep studying.